17.
Huh? 17.
17.
Okay. Why this strength is so less today? Any interview, etc. is there or not? Or for some exams?
नाही सर, माहित नाही.
Yes.
माहित नाही सर.
Okay. Let us start. I think we have covered 5 chapters in all respect. First 5 modules, module 1, 2, 3, 4, 5. We have conducted one test on first, second, and 3.1 chapters. We have conducted one practice test also on the syllabus, which we have covered till today, and one unit test. Now we'll start with the final chapter of this particular subject, power electronics, that is module number 6. And module number 6 is, yes, कोणाला काय बोलायचं आहे का? So module number 6, I will share the screen. This is AC to AC controllers. What are different types of converters which we have seen in power electronics? Different types of converters. Can you see the screen?
Yes, sir.
It is
Yes, sir.
AC voltage controllers, AC to AC converters. There are two main points in this: AC voltage regulators and cyclo converters. Both are AC to AC converters. Before that, I want to know what are other types of converters which we have studied in our power electronics. Yes, types of converters. What do you mean by converter? Converter converts one form of power into another form. That is the converter. It can be same voltage like AC to AC, DC to DC, but it can be fixed to variable. If you are talking about choppers, it is a DC to DC. That means a fixed DC is converted into the variable DC. That DC output can be more than the input or less than the input. So that is a converter. We have studied AC to DC converter. What is it? AC to DC converter. Yes. AC to DC converter. क्या बोलते हैं उसको? What is AC to DC converter called as?
Buck boost.
अरे AC to DC converter. Yes. AC to DC converter किसको बोलते हैं? What is it? हाँ. Yes. Who is this? Swamini Iyer. It is rectifier. Don't forget the basic things. AC to DC converter is rectifier, DC to AC converter is inverter. Why don't you unmute yourself while talking or giving answers? You can unmute and give the answer. Hmm? What is DC to AC converter? Yes. Hmm. Inverter, yes. Okay. It is inverter. What are different types of converters? AC to DC, DC to AC, DC to DC, AC to AC. AC to DC is rectifier. The output can be controlled or uncontrolled. That depends on what type of devices you are using. So there are two types: AC to DC rectifiers, controlled and uncontrolled. Then the second type is inverters. DC is converted into AC. The output is AC. The output of frequency of the output can be varied, can be controlled, and the voltage also can be varied. Then DC to DC, it is a chopper circuit which converts the fixed DC voltage into variable DC, and the last type is AC to AC converter that converts the fixed AC into variable AC. The voltage as well as frequency or either of the two, either only frequency or only voltage or both can be varied. So the AC to AC converter is a converter which converts the supply voltage, AC voltage, into the variable voltage. The amplitude can be varied or the frequency can be varied or both can be simultaneously varied. Again, there are two types of AC to AC converters: simple circuits which we use on off and phase control, that is simply introducing a thyristor in between the load and the source. We can vary the AC output voltage. Or a cycloconverter. Cycloconverter can also be used for conversion of AC into AC. This is module number 6. The topic is AC voltage controllers and cycloconverter. Cycloconverter is nothing but AC to AC converters. AC voltage controllers, that means only controlling, and cycloconverter converts. The topics which we have to cover in this particular chapter 6.1, principle of on-off control, principle of phase control, single phase bidirectional control with R load and RL load, and then introduction to single phase and three phase cycloconverters and their applications. So only these 2 points we have to see in this chapter: on-off control, phase control, and single phase bidirectional controllers with R load and with RL load, then single phase and three phase cycloconverters along with their applications. Let us begin with AC voltage controllers. What is AC controller? The power flow into a load can be controlled by varying the RMS value of the load voltage. The power flow into the load, where from the power is flowing? The power is flowing from the supply or source. The input voltage which is flowing into the load can be controlled by varying the RMS value of the load voltage. That means we are varying the RMS value of the load voltage by using the AC voltage controllers. This can be accomplished by thyristors, and this type of power circuit is known as AC voltage controllers. This can be accomplished by thyristors. That means the circuit in the block diagram here, you can see there is AC voltage controller. It consists of thyristor, and the thyristor is used as a switch here. And when we turn on that switch, the input is connected to the load. Here you can see this is the input source side and this is the output load side. In between there is a voltage controller block which consists of thyristors or thyristor. And once this is turned on, the input is connected to the load. We'll get the output voltage, and depending on how we are turning on the SCRs, at what point, at what firing angle we are turning on the SCR, from there you can get the output voltage or load voltage. So this way we can control the output voltage. This can be accomplished by thyristors, and this type of power circuit is known as AC voltage controllers. Why it is called AC voltage controllers? Because we are controlling the output voltage. And why it is thyristorized? Because we are using the thyristors for connecting the source to the load, or we are power flow from input to output in every half cycle for certain duration. In every half cycle, we are controlling some part of the voltage and transferred to the output. Means you can say chopping. We are chopping the voltage in every half cycle by using the thyristors. See, in on-off control, thyristor switches connect the load to the AC source for few cycles of the input voltage and then disconnected for a few cycles. That is called as on-off control. That phase control, thyristor switches connect the load to the source for a portion of each cycle. Thyristor switches connect the load to the AC source for a portion of each half cycle. That means in each half cycle we are allowing some part to flow to the output and some part we are controlling. That means we are not allowing to flow it to the output. I mean some part is available at the output from every half cycle, not the entire half cycle. We are controlling phase. We are triggering the SCR side different angles. Suppose alpha is equal to 15 degrees, then from 15 degrees to 90 degree, the output will be the voltage will be available across the output. Right. This is the phase control method. So there are two types of AC voltage controllers. They are on-off control and the phase angle control. Electronic switches connect and disconnect the source and load at regular intervals. Two types, just we have seen, phase control and integral cycle means that is nothing but on-off control. Phase control switching takes place during every cycle of the source, in effect removing some of the source waveform before it reaches to the load, chopping some part of the input and uh, processing it towards the output. Integral cycle, that is a on-off control. For n number of cycles, we are maintaining the switch in the on state. For m number of cycles, we are maintaining the switch in the off cycle, off period, off state. That means it is integral cycle or on-off control. This is same thing. The phase controlled AC voltage controllers has several practical uses. That means applications where, for example, light dimmer and speed control of AC motors. This is the main application of the AC voltage controller in speed control of AC motors, in induction motors and light dimmer circuits. In fact, we can use the triac also for this purpose, not only the thyristor. We can use the triac also. Triac is also bidirectional device, and that means it controls the voltage in both the cycles. Then a thyristor is not a bidirectional device. Then how it can control AC? Thyristor is unidirectional. It conducts in only one direction. We have seen its application in rectifiers. It converts AC into DC. Now, how to use the thyristor or SCR in the AC voltage controllers? Yes. How to use the SCRs in AC voltage control? Yes. Yes. How to use the SCRs in AC voltage controllers? Because it is a unidirectional device, it conducts in only one direction, and AC is a AC sinusoidal type, positive negative दोनों रहता है, positive half cycle, negative half cycle. So how can we control both half cycles by using the SCRs? Hmm? Hmm? Yes. How to use SCR for AC voltage controllers? We can use two SCRs connected in anti-parallel. What is track? Track is similar to two SCRs connected in anti-parallel. So if we can use the triac in AC applications, means we can use thyristors in AC applications. AC means AC to AC converters. Clear? If we connect two SCRs in anti-parallel, it can be used for controlling the AC voltage. one SCR will control the positive half cycle, the other SCR will control the negative half cycle. They are connected in anti-parallel. फॉरवर्ड डायरेक्शन वाला पॉजिटिव हाफ साइकिल ये करेगा और उसके एंटी पैरेलल में जो कनेक्ट किया दैट विल कंट्रोल द नेगेटिव हाफ साइकिल. So for AC applications, we can use either a triac or two SCRs connected in anti-parallel. For low voltage applications, low power applications, and low frequency applications, we can use triac for controlling the AC voltage up to 40 hertz, 40 kilohertz. We can use 400 hertz. We can use the triacs, and if it is beyond that, we can use SCRs. And similarly, for low power applications, low to medium power, we can use triac for AC voltage control, and for large power applications, we need to use the thyristors for controlling the voltage or power. Where are these controllers used? Industrial heating, on-load transformer, tap changing, light controls, speed control of induction motor, AC magnet controls. These are some of the applications of the AC voltage controllers, mainly induction heating or industrial heating, then light control, speed control of induction motors, and so on. AC voltage controllers can be classified into two types. Control part देखा हमने. Control part can be on-off control and phase control. But these voltage controllers can be classified into again two types, single phase and three phase, depending on the input source. Each type can be again subdivided into unidirectional or half wave control and bidirectional or full wave control. Now, what is meaning of unidirectional here is in one of the half cycles we are using the controlled device, that means SCR, and in other half cycle we are using diode which is uncontrolled. That means half is controlled, half is uncontrolled. That's why it is called as half wave control or unidirectional controller. Not unidirectional only, it is unidirectional controller, means controlling in one direction and uncontrolled in the other direction. That's why it is called as unidirectional. It doesn't mean that it conducts in only one direction. It controls in one direction. The other direction it is uncontrolled. That's why it is called as unidirectional controller or half control. Similarly, what is meaning of bidirectional or full wave control? Here in both the half cycles we are using the thyristor as switch. Thyristor is controlled device. So we are controlling both the half cycles, positive as well as negative. That means the power flowing in both the direction is controlled. Controlled direction, here direction is associated with control, not flow of current. Unidirectional control means controlling the power flow in one of the cycles and not controlling. One of the half cycles means either positive or negative. You can use the controlled device, and in bidirectional we are using both the switches as SCRs. So these are the types of the AC voltage controllers. First, depending on what type of control technique is used, they are classified as on-off control and phase control, and then the AC voltage controllers can be classified into two types depending on the source or input, that is single phase controller or three phase controller. And again these two types are divided into two subtypes, that is unidirectional or bidirectional, or half wave and full wave control. Since the input voltage is AC, thyristors are line commutated. What is meaning of this? Yes. What is meaning of this? Since the input is AC, we are using natural commutation. Yes. Then where we are using forced commutation? Hmm? Voltage is AC. Input voltage is AC. Thyristors are line commutated. We have seen that there are two types of commutation, natural and forced. Whenever there is AC input, we use the natural commutation. The SCRs are turned off by natural commutation. Whenever there is the DC input, we have to use the forced commutation to turn off the SCR. So here, as usual, AC is the input. The thyristors will be turned off by line commutated or natural commutation. Now, typical phase control thyristors which are cheaper are used. Now, what is phase control thyristor? There are two types of thyristors, inverter grade and converter grade. Inverter grade thyristor means the thyristors which are having higher switching speeds, turn on turn off times are less. Switching speed is high, and such thyristors are used in inverter applications where we require the very high frequency output. That's why they are used in inverters. That is called as inverter grade SCR, and the other SCRs are converter grade SCRs. That means they are used in rectifiers, converter AC to DC conversion में वहाँ पे frequency is not that much important. जहाँ पे frequency important नहीं है वहाँ पे you can use the phase control or converter grade thyristors. So here in AC applications we are using the phase control or converter grade SCRs which are cheaper. That means if we consider the cost of these two types of thyristors, converter grade and inverter grade, converter grade thyristors are cheaper as compared to the inverter grade SCR. So here the frequency is not of that much importance. That's why the converter grade or phase control SCRs are used. For applications up to 400 Hz, triacs are used. That means for low frequency applications, we can use triac instead of two SCRs in anti-parallel. We can use only one triac for the applications up to 400 Hz. In your oral exams, they can ask, we have a choice to use a triac or two SCRs in anti-parallel for AC power applications. How will you select these two choices? On what factor you will decide which option is better? So your answer must be for low power applications, for low frequency applications, we can use triacs, and for high frequency applications and high power applications, we can use two SCRs connected in anti-parallel. Both the combinations are used in AC voltage controllers. Either you can use a single track or two SCRs connecting them in anti-parallel. So you should be aware of about these small things. Where to use triac in AC applications and where to use SCRs in AC applications. You should be able to answer this. For low frequency, we can use triac. For high frequency, we can use SCR. Similarly, for low power, we can use triacs. For high power, we can use SCRs. What are different performance parameters? An AC voltage controller produces a variable AC voltage at a fixed or variable frequency. See, this sentence is very meaningful. You have to remember this. AC voltage controller produces variable AC voltage, right? That means you are converting a fixed AC voltage into the variable voltage. That means you are varying the amplitude at a fixed or variable frequency. The frequency can be maintained or it can be variable. Maintain means आपका input voltage frequency अगर 50 hertz है तो you are maintaining it as it is. At the output also you are getting 50 hertz. And variable means at the output the frequency is not similar to the input frequency. If you are applying 50 hertz, you can get 70, 80 or 30, 40 hertz. That means you are getting the variable frequency at the output. So the output voltage or output frequency or both can be varied. Input source is a fixed voltage and frequency AC supply. Generally 230 volt 50 hertz input is used. That means it is a fixed source. Generally 240 volt 50 hertz 120 60 is depends on some particular applications. The output should ideally be a pure sine wave. What is our objective of this AC to AC voltage controller is to get the variable voltage or variable frequency or variable frequency variable voltage sinusoidal output from the fixed sinusoidal input. The output should be pure sine wave as input. This is the ideal expectation from the AC voltage controller. Practically ऐसे नहीं मिलता है, but it is expected to have the pure sine wave at the output. See, this is a general block diagram of a AC to AC voltage controller. You are applying AC at the input. This Vs is the source of AC voltage. प्लस माइनस दिखाया मतलब यहाँ पे ये दिस इज नॉट डीसी दिस इज एसी. यहाँ पे यू कैन कनेक्ट these two wires and show a circle, and in that circle you can draw single sine wave. That indicates it is the AC applied to the controller circuit. Then here you can see there are two parts in this block, AC and AC. That means AC is applied and we are getting AC itself, but it is converted. So this box is controller box, AC voltage controller box, and at the output you are getting the AC itself, but of different magnitude or different frequency or both are different. Here in the waveforms you can see that the is of this type. Is it pure sine wave? No. यहाँ पे there is some zero load voltage portion. That means it is intermittent. It is not perfect sine wave. You can have this type of output. Why it is there? Because we are maintaining the switch, that is thyristor, in the on state for certain duration by applying the gate pulse, and at this point the SCR will be turned off by natural commutation, and we are maintaining the off state of both the devices for this particular duration. We are not applying the gate pulse at pi is equal to alpha. Alpha is equal to pi. At this point, we are not applying the gate pulse. We are applying the gate pulse at pi plus alpha. So from pi to pi plus alpha, the SCR is not conducting, so we are not getting any load voltage. This is the output voltage and this is output current. It depends on what type of load is used. If the load is inductive, we can get the current for longer duration than the voltage. That depends what type of load you are using. Now different performance parameters of this AC voltage controllers are, these performance parameters of AC voltage controllers are similar to those of diode rectifiers. Diode rectifiers means uncontrolled rectifiers in which diodes are used as switches, and as diodes are used as switches, we don't have any control over the output. We are going to get the fixed output. So the performance parameters of voltage controllers are similar to the uncontrolled rectifiers. Now what are performance parameters of the uncontrolled rectifiers? The input power PI, that means VI into II or VS into IS. Multiplication of input current and input power, you will get the input power, that is PI. RMS input current, total harmonic distortion factor THD of the input, crest factor of the input current, that is CFI, crest factor of the input current, harmonic factor of the input current, form factor of the input current, transformer utilization factor of the input, ripple factor of the input current. So these are the performance parameters on the input side of the voltage controllers, AC voltage controllers. Similarly, there are some output side performance parameters for these AC voltage controllers. Those are output power. As like input power, there is output power, that is product of the output voltage and the output current V0, I0, then RMS output current I0, output frequency F0, then THD, total harmonic distortion factor of the output voltage, crest factor of the output voltage, harmonic factor of the output voltage, form factor of the output voltage, ripple factor of the output voltage. These are the performance parameters at the output side of the AC voltage controllers. Why we need to measure these parameters? We have to find out the performance of the voltage controller, how it is performing, how much input we are applying and how much output we are getting. That is the main objective of measuring these parameters. Suppose we are applying 230 volt 1 ampere, that means 230 volt to 230 watts, and if you are getting 130 volt 0.5 amperes, that means we are getting 50% at the output. 230 वोल्ट अप्लाई किया है, 115 मिल रहा है, and 1 ampere input current है, we are getting 0.5 ampere at the output. 50% लॉस हो गया. Principle of on-off control. The first method of the AC voltage controller. How the AC voltage can be controlled by using this method. The principle of on-off control can be explained with the following single-phase full-wave controller. Why it is called as full-wave controller then? Because यहाँ पे देखो दो SCRs यूज किया है, एक पॉजिटिव डायरेक्शन में कंट्रोल करेगा, दूसरा नेगेटिव डायरेक्शन में कंट्रोल करेगा, इसीलिए उसको बाय डायरेक्शनल या फुल वेव बोलते हैं. फुल वेव मतलब दोनों हाफ साइकिल में कंट्रोल है अपने पास. अगर यहाँ पे एक डायोड होता तो दोनों में से, if suppose T2 is replaced by a diode, then can we call it as full wave control? Yes, can we call it as full wave control? Can we call it as full wave control if one of the SCRs, suppose SCR2, T2 is replaced by a diode? Can we call it as bidirectional or full wave control? Yes. If this SCR is replaced by diode, then it will be a half wave control or unidirectional, and you can maintain the switch in the on state for n number of cycles. Here you can see n. N indicates the number of half cycles in which the SCR is maintained in the on state, and you can see here M indicates the number of half cycles in which the SCR is maintained in the off state. So M is off state, N is on state. So we are using on and off control. Whenever the switches are in the switch is in the on state, that is called as on control, and when the switch is in the off state, it is called as off control, on off control. And we are simultaneously applying, not simultaneously, we are applying the gate pulse at omega t is equal to 0. Alpha is 0 here, and for negative half cycle we are applying the gate pulse to the SCR2 at omega t is equal to pi. That means at the instant the zero crossing, at the instant of zero crossing, we are applying the gate pulse to the SCR, and at omega t is equal to 0, we are applying the gate pulse to the SCR1. So there is no delay here. It is not phase control. It is on-off control. You can see the gate pulses G1 and G2. So we'll stop here today and continue in the next lecture, the rest of the part. Just I will take the attendance. ठीक है.
Okay, sir.
We'll stop here. Okay. Bye.
Bye, sir.